Şimdi büyütelim. Sesim benim geliyor mu şu an size?
Evet evet duyuyorum.
Evet
Ben şu an
geliyor.
YouTube'da bir açtım ama Umutcan'a bir şey yapalım. Onu bir kesin.
Heh, evet. Şu an
Geliyor ama bir görüntüde bir sıkıntı var mı? Sanki biraz değişik görünüyor.
Çok bilmiyorum. Bir bakayım.
görüntü hareketsiz ya. Böyle bir
Evet, o
sıkıntı var.
bir olay var, onu hemen bir düzelteyim. Ses geliyor mu peki orada? Sesim
Bir
benim
saniye,
geliyor mu
ona
şu an
ayrıca bakmam
size?
lazım.
Evet evet duyuyorum.
Ses geliyor.
Ses de gelmiyormuş.
Biraz gecikmeli geliyor. O sıkıntı değil. Sadece şu görüntüyü halledeyim hemen. Tamam, başlayabiliriz.
Ses hiç mi gelmiyor?
Yok, şeyde ses geliyor. İki tarafa da. Şu an sizin sesiniz de geliyor. YouTube'a da geliyor. Ben ona baktım.
Yok, yanında kardeşim var da o da YouTube'dan bakıyor. YouTube'dan ses gelmiyor mu Deniz şu an?
Telefondan açtım bilgi. Ha şimdi geliyor.
Ha, gecikmeli geliyor.
Gecikmeli geliyor. Aynen.
Evet şu an geliyor.
Tamam.
Ama görüntüde bir patates var şu an. Bunu bir halledelim ama.
Görüntü mü sıkıntılı?
Zoom bir stuck oldu da. Aslında bir sıkıntı olmaması lazım şeyde. Yani bende Zoom dondu. O yüzden görüntüde bir patates var. Bir bakıyorum. Bir koskoca hemen
Arka planda çalışan programlara. Eğer arkada bir şeyler açıksa kapatmak isteyebilirsiniz. Chrome'dur.
yok, hepsini kapattım aslında da ben bir Zoom'dan çıkıp gireyim, hemen düzelir o Bigos'ta.
Tamam.
Meeting'den bir çıkalım. Bir saniye. Evet.
Onlar epey ilgi çekiyor aynen.
Urkan
Hello. Geldim ben.
Hello.
Tamamdır. Şu an şeyde düzgün. OBS'de de düzgün.
şu
Şuradan
an
da
görüntü yok ama
görüntü bende geliyor. Size de bir gecikmeli gelecek her zaman olduğu gibi.
ben bir bakayım.
Sadece şu
Canlı yayın herhalde bir 5-10 saniye lagli geliyor. Anladım.
Aynen. Sadece şu görüntümüz biraz zoomlu görünüyor da bayağı dibimize kadar girmiş. Onu bir fixleyebilirsem her şey çözülecek. Evet.
Bu yayın işini çözemedik hocam.
Yok halledeceğim. Korkmayın.
Olur böyle. Zaten ilk interview galiba.
Aynen. Ya bir kere yaptık ama onda böyle videolu değildi Zoom üzerinde. Şeydi, sadece bir slide anlatıyorduk. Evet, iki kere.
Anladım.
Hemen hallediyorum. Şu an ben bir YouTube'a bakayım nasıl görünüyor diye. Sadece sizin suratlarınız görünüyor, onu bir düzeltelim.
Hala zoomlu gözüküyor yalnız.
Yok o gecikmeli geliyor da bende görünen şey daha... Bende yani preview'u görünüyor oraya gitmeden önce ne gideceği birkaç saniyenin de. Şu an fixlemiş gibiyim çünkü YouTube'u gösteriyor. Bakayım. Şu an YouTube'da görünüyor mu düzgün? Olabildiğince görünmesi lazım ama.
Ya en azından gözüküyor, tamam.
Şey mi görünüyor? Tamam.
Uzak gözüküyor ama normal.
Tamam, onu da halledebiliyorum şu an. Tamamdır, her şey hazır. O zaman ben bir başlayayım, bir sıkıntı yoksa şeyden. Biraz acele oldu ama girişimiz. Şu an fixlemiş gibiyim çünkü YouTube'u gösteriyor. Tamamdır. Bakayım. Heh. Şu an YouTube'da görünüyor mu düzgün? Olabildiğince görünmesi lazım ama. Hello all, and this is our first RL Turkey interview meeting. And today we are going to interview with the Nazım Kemal Ure. He's a professor, assistant professor at the İTÜ, and he's working on the multi-agent systems. We have a lot of questions and things to talk about him today. And this interview will be in the English, and the reason for that to reach our audience a little bit international. And if you don't know about the RL Turkey, we are a new reinforcement learning research and application group, which we mostly operate on the Twitter. And the reason for that, we want to be able to communicate with the most of the deep learning and other communities. And we have a Discord channel that's more like private, which we get invite people time to time. And if you want to be joined, we have currently opened a new sign-up form. And today we are gonna interview Mr. Nazım Kemal with Umutcan here with us. And yeah, Umutcan, can you give a voice? Are you here?
Okay. I think we can start the interview. Nazım Hocam, thank you for joining us today.
Thanks for having me.
I think Urkan wants to start with a basic RL concept.
Hocam, do you prefer Nazım or Kemal?
You can call Kemal. Yes.
Kemal, can you introduce yourself, hocam?
Sure.
Yeah.
Sometimes I can't hear you well. Okay, sure. So yes, I'm an assistant professor at Istanbul Technical University from the Faculty of Aeronautics and Astronautics. And I am mostly working on deep reinforcement learning with applications to multi-agent systems, but not only multi-agent systems, but also a lot of autonomous systems in general. And also how we can apply reinforcement learning to solve complex decision-making problems in general. So that is my main study area. And because I'm coming from an aeronautical background, we do a lot of aviation applications, but we are not constrained to that. I'm also a part of a bigger research group, ITU Artificial Intelligence and Data Science Research Center, which was founded only a year and a half ago. I am also the vice director of this facility. And there we collaborate with a lot of researchers from ITU, where we actually do a lot of collaborative research funded by industry. And we are trying to solve industrial problems, and we also apply to a lot of scientific projects. So that is mainly what we do as a big research unit in ITU. We try to basically, develop novel artificial intelligence methods that are focusing on solving both the scientific and applied problems. So in a nutshell, that is who I am. And maybe I can tell you a little bit about my past.
Yeah, that would be helpful, yeah, for people.
Sure. Well, I'm actually not trained as a computer scientist, so that came later. My actual background is from aeronautics and astronautics. So I graduated from ITU as an aeronautical and an astronautical engineer. And at that time, I was actually mostly working on applications of control theory to aircraft. So mostly what I was doing was designing autopilots for unmanned aerial vehicles, specifically aerial vehicles that can maneuver in an agile manner. So that is what I was doing in master's school. And at that time, like I said, I was mostly doing control theory, a little bit of planning, but not a lot. So I didn't actually have much background in computer science. Then we did a lot of actually work on that subject. And then for my PhD studies, I went to United States. I went to study at MIT.
Yeah.
And at MIT, that is where I was introduced to artificial intelligence and to reinforcement learning, to be specific. And actually, it was quite a surprise for me when I got there. So this is 10 years ago, at 2010. And I was actually going to study with my advisor was a person who was very famous in control circles. And his name is Jonathan Howe. And when I went to study with him, I was expecting to work on control. So that is what I was expecting, because that is what he did mostly, and that is where my background was from. And to my surprise, he told me that, no, you are going to work on reinforcement learning. And I was like, what is going on? And like I said, at that time, this was like 10 years ago, and reinforcement learning was not popular at all. So right nowadays, if I tell someone that you are going to study reinforcement learning, they get really excited. You know, it is a lot of hype around this popular subject. So, but at that time, 10 years ago, reinforcement learning was definitely not popular. For example, if you went to a conference like ICML or NeurIPS, there would be just a single track, just like one session for reinforcement learning. And now you go to ICML, there are like parallel sessions for reinforcement learning. It is crazy.
Yeah.
So that got me a little bit worried in the beginning, because I wanted to do controls. Why am I going to do this, reinforcement learning stuff? But then I, got into it. I learned a lot. I started studying probability theory, optimization, and I was really lucky at MIT to, get these courses from the people who basically invented this stuff. Yeah, so that was that helped a lot. So by studying about these subjects, that is how I became familiar with computer science and reinforcement learning and artificial intelligence. Another thing that motivated me about the research project I was working on. The research project was funded by Boeing company, and they were interested in using reinforcement learning to how to coordinate multiple aircraft for doing surveillance missions. So you got a group of aircraft, and then you want them to do some kind of a surveillance mission. So they take off from the base, they go to a predestined area, and they just observe the activities in that area. And the decision-making part of that process is these UAVs, these drones. Nowadays, drones is a more popular term, so I'm going to say drones. But back in the day, we used to call them UAVs all the time. So these drones, they've got limited life, either because of the battery limitations or the fuel limitations. So you cannot keep them forever in the search area. Every once in a while, you need to call them back to the base area so that you can repair them, or you can refuel them, or change the battery, stuff like that. So there's a very interesting decision-making problem there. So you can just keep calling these drones back to the base all the time. So you change the battery so they never crash. But if you do that, then you do not spend a lot of time doing the mission, which is not good. But if you try to do the mission all the time, if you try to drive these drones to their limits, then they can crash. So there's a very interesting high-level decision-making planning problem going on top of all the control and sensing problems. And I got really fascinated with that problem. And then more I read into reinforcement learning, more I become fascinated with the subject overall. Because I was really surprised by how general it is. At first, when I read it, when I started studying reinforcement learning from the classic textbooks, well, this just looks like control theory. Like, I mean, there's a dynamic system. You need to learn a policy, which is kind of like a control law in control theory. So it all felt familiar, but once I started to learn more about Markov decision processes in general, I was fascinated. I was awestruck by how general the problem formulation is. Like, this not only includes control theory, it includes all the discrete stuff, all the model-free stuff, everything else. So when I realized that MDPs and reinforcement learning in general is a much bigger framework where you can study all kinds of decision-making problems, then I said that, yeah, I mean, I really like this area. I'm going to continue doing my PhD on this area. And like I said, at 2010, 2011, this was a brave decision because it wasn't that popular. Machine learning was popular. Machine learning was always popular. But reinforcement learning was kind of like this niche subject where a lot of people wanted to do something, but there weren't much practical results. And to be honest, at our case, that is what we were struggling at. We were trying to take existing techniques and try to solve problems that were just out of reach for the reinforcement learning at that time. The problem that I mentioned, this drone coordination problem, the classical methods they just didn't work when you increase the number of drones. So when you go from 3 drones to 4 drones, your search space, it becomes it becomes huge. So none of the classic methods work. And then you need to do some approximations. And most of my PhD was about how to do intelligent approximations, in the sense that instead of doing a fixed approximation, can I also learn how to approximate this problem better when I am getting observations from the problem? So it was kind of like a model-based reinforcement learning framework where you are learning the approximation along the way while you're also solving the problem. And like I said, this was all before deep learning stuff.
Yeah.
So we didn't have deep neural networks. Of course, they were there, but to be honest, nobody paid much attention to them because they didn't truly work at that time. So that is my PhD work, and that is how I got introduced into the field of multi-agent systems and reinforcement learning in general. And I was really lucky. I had great colleagues at MIT. I had people who helped me set up experiments. I learned a lot from them, also in terms of mathematics and applications. And then after I graduated from MIT, my plan was to always return back to Turkey. I was always very motivated by, once I learn how these things are done in United States, I can bring this knowledge back to Turkey and do great things there. So that was a big motivation for me always. So when I returned back to Turkey, I became an assistant professor at Faculty of Aeronautics and Astronautics. Unfortunately, this was at 2015. When I returned, machine learning and reinforcement learning in general was not that popular at Turkey at that time. It was very popular in the world, but Turkey was a little bit lagging behind in terms of the hype in deep reinforcement learning, especially. So for the first 2-3 years when I was at ITU, I didn't actually do much machine learning. Instead, I went back to my old field, control theory, and we did a lot of applications of dynamical systems and control theory with a lot of defense companies. So that is how I spent most of 2015 to 2017. But then at 2017, I won a very nice grant from European Union. It is the Marie Curie Fellowship, where they basically give you a considerable amount of money to do basically research on any topic on you choose. And that is when I said, finally, I can bring back reinforcement learning stuff back into my current studies. And there, basically, what I did was I took the ideas from the Boeing project that I worked at during my PhD, which was mostly a defense application, and try to convert that into a more civilian application of how you can use multiple drones for forest firefighting. So that is what my Marie Curie project was about. Basically, applying the same algorithms at the core, but now because deep reinforcement learning was a thing, we got rid of all the old stuff and replaced them with the shiny new deep neural networks. So that is how I got back into deep reinforcement learning research. And around at that time, I was also lucky. We founded the ITU Artificial Intelligence Research Center, and then things got more serious. It became much more easier to get funding for projects. And now, currently, as of now, we have, I believe, 3 to 4 major projects, all funded by industry or European Union, where we are working on various aspects of how to apply deep reinforcement learning to challenging problems. And I've got a moderate-sized research group consisting of something around 15 to 20 students, graduate students mostly, who are, doing their thesis and writing papers on the subject. So I believe that's a good summary of where did I come from and where I am. And yeah, I mean, I can also talk more about the recent projects.
Thank you for the introduction. That was I had questions that which all covered now, and I don't need to ask now, but I can add some or ask some additional information. So you mentioned you didn't study computer science before the PhD. That must be challenging because probably other people had some background in the computer science before. And how was the challenge there? It must be hard, but yeah, we can hear.
Well, it was very challenging. Yeah, like computer science was something that I've never considered before. Even when I was a child, I was always fascinated by space in general. So
Yeah.
when I was a child, my dream was to become an astronaut or something like that. Then I realized that that is not possible. Then I said I'm going to do space science, study astronomy, and stuff like that. And then they told me that there's no money in that. Like you will be miserable if you study space sciences. And then I said, okay, then I will do space engineering, like astronautical engineering. And that is, how I started to do this stuff. And of course, aeronautics is a very closely related area. And to be honest, I wrote my first code when I was at the second year in my university. Before that, I always liked computers, but I only liked playing games on them. So that was my limitation. That was a bit about me and computers. I just played games on them. Like writing programs, that was like magic to me. And when I got introduced into coding during my university years, I mean, I really liked it, and I was kind of like bummed that I didn't find out about that before. But even that, again, the computer science and stuff like that was very far away to me. Like I said, I was trained as a classical aeronautical engineer. And then, yeah, it was really challenging when I got into my PhD. I remember that one of the first courses I took was actually dynamic programming and optimal control by John Sitsiklis, like one of the leading figures in that area. And I think it was a major mistake actually taking that course because I didn't have a good background in probability theory. I knew about the basics, but like when you do control theory research on deterministic systems, you don't get much exposure into probability theory, and especially discrete discrete probability theory. Like you don't get any background on. And then I started taking this course, and I remember sitting in that course and thinking to myself, well, this makes no sense at all. Like, what is going on here? And I also remember that MIT is a highly competitive environment. So the exams were super difficult, especially compared to ITU. I would think that I took an exam and I would say, yeah, I think I will take 60 from this exam. I will get 60 and the average will be 40. So I will be good because I was thinking like ITU. But then the exam results would be announced and everybody would got like 90 from the exam. So the average grade was 90 and I got 60. So it was really frustrating for me. But then what I did basically was, once I understood that the problem is not the courses, problem is fundamentals. I do not have good fundamentals to understand that subject. That is when I sat down and I grabbed some, books, for example, on algorithm analysis, like how do you compute the complexity of an algorithm. Again, I took some probability classes on basic undergraduate probability. And then once I understood the fundamentals very well, everything got much easier. Of course, the experience also helped because I was working on a computer science project, because I had to apply all of the stuff I learned. It really helped a lot. Of course, it also helped a lot that I was surrounded by, people who are insanely smart. So when I got a question, when I needed help, there was always someone who knew the solution to that problem. So that all helped a lot. So the first year was very challenging, but then gradually it became easier. So that is how I actually discovered that fundamentals is most important than everything. So whenever students come to me for advice, like this subject is too difficult, I don't understand what is going on, or I am trying to read a paper and I don't understand the contents of that paper, that is the first thing I recommend. Go study the fundamentals. Like even if necessary, pick your Calculus 101 book, your linear algebra book, and study them from scratch. Make sure that you are sitting on a solid foundation, and then everything becomes much more easier. So that is kind of like my experience.
Yeah, that was one of the questions I also had in mind, like a book recommendation that you were learning that was very helpful, which you also answered, and the teacher maybe affected your educational life during that. And those were the things. And I think the first part of this interview was mostly complete for me. And Umutcan, want to have anything in mind, or we
Yeah,
can
actually,
continue?
we can learn from Kemal Hoca how to start RL or the mathematical things in RL.
Oh, okay. How to study doing reinforcement learning research?
Yeah, how to start.
Yeah,
with
so
basics.
Yeah, that's a difficult subject. Well, the one thing you should understand when you are going into reinforcement learning is, and I think that is one of the reasons why not a lot of people are picking reinforcement learning as the primary research area. The startup cost is much higher compared to
Yeah.
compared to classical machine learning or supervised learning in general. And the problem there is you need to have a lot of background in order to truly understand what you are doing. In supervised learning, if you understand like how does curve fitting works in general, and if you understand like gradient descent and stuff like that, you are mostly set. And it also helps that there are thousands of supervised learning tutorials out there where you can just pick a library, write a few lines of code, and the magic happens. Uh, Unfortunately, in reinforcement learning, even the simplest problem, getting it to work, takes a considerable amount of time and frustration. So for reinforcement learning, also in order to understand truly what is going on with reinforcement learning, you need to really have a solid background in two topics, optimization and probability. So if you only have a vague idea of what these things are, you are not going to survive in reinforcement learning, or you will just, you will just run other people's codes and think that you are doing something meaningful. So that is what I would recommend for reinforcement learning. If you want to get into reinforcement learning, first learn about, again, fundamentals, optimization and probability theory. So learn about these well. And in order to truly understand what optimization is, you need to really understand linear algebra and calculus.
Yeah.
So those are two very, very important subjects. One thing that is, again, troubling me about I think what is troubling about the current trends in machine learning education, we have got abundance of like online tutorials where people can learn about machine learning and reinforcement learning in general. And they are like what I would say quick and dirty ways of getting into research.
Yeah.
And this can be cool if it motivates you. Sometimes you need to, run a program and see that it works, and that is really motivating. But in the long run, you just end up becoming a consumer of these things. Like you never become a master of them. You never can develop your own algorithm or solve your own problem. In order to do that, you need to learn about fundamentals. So I would recommend investing a lot of time into probability theory and optimization. And of course, coding is also super important. I'm not saying that you just need to learn about the theoretical stuff. Coding is super important because that is actually what I found about a lot of students. One of the difference between them, students who can code fast and code well, they really, it's a really huge advantage in writing papers and also developing your own research ideas. So I've unfortunately seen a lot of students where, because they are lacking in coding skills, they've got great ideas in mind, but because they cannot implement them, on the long run, they cannot test their ideas well, or even if they try to test, their code is very inefficient, so they end up waiting like a month to get a simulation result. So this is also very inefficient. So you need to learn both the theory and both the technique, the implementation very well. Kind of like actually how you play a musical instrument. Like you need to know the music theory, and at the same time, you need to learn how to play your instrument. Only when these two come together, then you can, create output. So that is advice. Yeah.
Actually, I remember my first time when I read the Sutton's book.
Yeah.
It was very challenging.
Yes. Yeah, a lot of people get introduced into reinforcement learning with Sutton's book. Sutton's book is great to learn about the fundamentals of the subject, but people who knows me know that I'm not the biggest fan of that book. I'm not saying anything about Sutton. He's the greatest researcher. He's a great researcher. He's the father of reinforcement learning and all. But when it comes to, exposition, for example, my favorite book would be the book by Babushka and Bouchaneau. It is called Approximate Dynamic Programming and Reinforcement Learning. And so I was reading Sutton's book and book by Bouchaneau at the same time. And like I said, Sutton's book is great, but it just talks a lot, and there's a lot of biological, motivations and stuff like that. You can get lost in it. But on the other hand, the book by Bouchaneau, it just gives you the pseudocode. It is a very clean and, it's a very clean description of what problem you are trying to solve. Here is the algorithm, and here are the results. So so I really like book like that much better. So if you are having problems with Sutton, I would recommend reading that.
Thank you for that.
That was very helpful, and I had one question in mind that I wrote. And
Sure.
in the 2000, since the 2012 or 13 or something, there are a lot of hype during regarding to like deep learning and machine learning in general with like OpenAI, DeepMind, whatever, and robotic challenge, new projects, and facial recognition system, etc., and drones, of course. And most people see these like computer science undergraduates and electrical engineer students, etc. They see this and they want to say like, I want to become a AI programmer, AI software engineer, whatever. But then they basically just, like you said, copy the codes from the GitHub that already perfectly crafted and perfectly efficient, and they run them and maybe run some Keras code and some little modification, and they think like they start to become an AI software engineer. But in the general, I mean, in the industry, you will probably tell more about it later. That's not the case. You won't have like a much big data set or perfectly crafted things like that. And I want to say like I want to learn your opinion about how to do you. Let me put this in the sentence, and what will be the perfect way to get with the started in the software engineering part of this, because I believe in my opinion you should have some academic degree, or you should be very good at like some understanding of the concept, not necessarily degree or something, but degree is very easy way to get these skills, because not all the self-skilled programmers can learn the fundamentals very well, and degree basically confirms your education. You basically learn, force it or whatever you had to learn because to pass write papers. And how do you recommend newcomers that's hyped by AI to start? Do you recommend some writing code or learning basic? You basically covered it, but just want to make new undergraduate students make their mind clear.
Okay, so especially if you are getting into the research part of RL, not the user part of RL, let's say, or again, artificial intelligence in general, one thing you need to realize very quickly is research is a game of patience, okay? So the sooner you understand this, I think the sooner you can actually make decisions about your career, like, do I really want to do this? So one thing about this hype, and one thing that's troubling is, like I said, when people start getting into it, there are these perfect examples of codes, there are perfect applications where the data is clean and everything works, and then people become illusioned by it and think that this is great. Like, I will just take a model, I will put a lot of data, and the magic will happen. And then you start getting into real problems, whether it's a research problem or the problem you are trying to solve in your workplace as a business problem. And you quickly realize that there's a huge gap between what you see in the papers and what you can apply in practice. And that is where you need to develop your own ideas. Like, you need to come up with your own solutions to the problems that nobody knows how to solve. So that is what research is. Like, it is about solving problems that nobody knows answers to. So that is really different from solving an exercise from a book. In a book, all the exercises have solution manuals. In the real research, nobody knows the answers to the problems that you are trying to solve. The sooner you understand this, then I believe that is the point where you can say, hey, like, do I really, want to put my whole life into this, put my career into this? Because it's a very important decision. Because when you are solving real problems, research problems, that doesn't happen in a night, or that doesn't happen. You cannot solve a problem in 1 month or 6 months. Sometimes you would need to spend 2-3 years in order to solve a novel problem if you really want to make a good contribution to it. And that is really a game of patience. So if you just think that, there are this magical stuff out there that I can take and use it to solve my own problems, that is not going to happen. You need to put the blood and sweat into it. And I believe a lot of people do not really understand that when they start getting into artificial intelligence world.
Yeah.
So then they become really disappointed when they see that a lot of real problems out there cannot still be solved by using the current methods. You need to develop your own ideas, and developing your own ideas can take a lot of time. So it's a game of patience. So that is, first of all, what I would recommend. Learn how to be patient. Most of your ideas, most of the things you implemented for the first time, they are not going to work. So you need to be ready to face that challenge. And then at that point, you need to start realizing that you cannot do this alone. Okay, you cannot just take a program and randomly try new ideas. You need to start reading papers. You need to start looking outside. And this is, again, what a lot of people doesn't realize when they start machine learning research in general, like how much stuff you really need to keep track of, like how much stuff you need to read and consume every day. For example, a common mistakes a lot of beginners do is they take a problem and they just read maybe a few papers to get an understanding of the problem, and then they just started working on their own code without never looking at new papers that are coming out and, you know, what can I learn from these new methods. So that is one of the most important things, and I tell this to my students all the time: always be reading. Like every day, read at least 5 papers that are relevant to your area, and at least 5 another papers which seem like connected to your area, but not necessarily is trying to solve the same problem that you do. You need to be getting your food. You need to be getting your nutrition from all the different places. So yeah, just to sum up, that is what I would recommend. Learn how to be patient, read a lot of papers. I've already talked about the importance of fundamentals. And yeah, I mean, that is about it. And I would say also find a good advisor. Life becomes much easier when you can find someone who has more experience on the subject and can guide you in the correct direction. And that is where the importance of doing a PhD comes in. I believe the most important part of the PhD is not about which schools you go to. It is about what kind of people you are surrounded with when you are doing that PhD. If you have the opportunity to do a PhD thesis with someone who is very well experienced with, you know, for example, reinforcement learning research, you should definitely do it. That is more beneficial than everything else. And if you do it with someone who also has a large group and there are other people in the group, that also helps a lot. So the biggest thing I got out of MIT was actually my colleagues, the people who I was surrounded with when I was doing this research, who actually continue to do great stuff. Some of them are in Facebook AI, some of them are in Google DeepMind. And you know, they are all doing great artificial intelligence research, and we learned together with them when we were doing my PhD. So basically, surround yourself with smart people, and the best way to do that is to go do a PhD in a good group, read a lot, and write a lot of code, and learn your fundamentals. So that is what I say.
It was very helpful for people. And I have a last question regarding to this topic, and that was about, I mean, yes, you are decided to become a researcher, you will devote your life. Now there's a problem of the more, not like one problem, but there's a lot of problems when you start to divide your path to researching, and how to get deal with the hard professors, how to get funding to projects, like how to be noticed in the industry for like internships or maybe jobs during your PhD or master, and how to get more connections. This more like a social problem, or maybe you can deal with better understanding. Tell us better.
Oh, so if I understood right, you are talking about how to
the challenges in the like researching in the social manner, like how to deal with the academia.
With the challenges outside of doing research. Is that
not related to research itself, but people behind it, how to get like funds, how to get your projects noticed, how to get maybe
so there's a lot of managerial aspects as well once you are doing research. So when you're a PhD student, it is actually not that difficult, because a PhD is what I would say, it is like a research job that is pretty much, you know, it has like some boundaries. So you usually do what your advisor is telling you. And I think in your PhD, you shouldn't worry too much about the other stuff. I would say that when you are doing your PhD, only focus on doing good research. That is actually what I tell to another advice I tell my students. You can start worrying about a lot of stuff like money, career, and other social stuff, and I don't know, other stuff related to your life. But at the end of the day, so PhD is kind of like a phase of your life when you really need to start outputting some solid material in terms of research output. So I would recommend when you're a student, do not focus anything other than writing good papers and doing good research. So that is what I would recommend. After that, after you get your PhD, that is another topic. But in terms of finding jobs, I would say nowadays, especially, it is not really a huge deal if you did a PhD on AI, and if you produce some good research outputs, you will never find any trouble finding a good job nowadays. So because AI is so hot, for example, let's say that you graduated from the university and you got 2 or 3 papers in top AI conferences such as ICML, NeurIPS, and the related conferences. You can go anywhere in the world. I would say, like, you can go to any institution in the world, and if you don't do something crazy in the interview, you will get into it. So I would say do not worry about the job part. But for example, about the funding part. So the funding part that is the frustrating part when you go from a PhD to a full professorship. So yeah, unfortunately, a large portion of my time goes to how to find funding for my projects. And what I would actually recommend for that is, again, following the trends help a lot. Like, just, again, read a lot and see what are the relevant problems in the industry, so that when you are talking with the industry, you can actually point them towards the right direction. So that helps a lot, especially if there are any young professors out there who are, starting their own lab and looking for funding. Yes, you can always apply to national funding, but that is usually very limited. You cannot get a lot of funding out of it. So most of the real funding comes from private sector and also the European Union. And then you need to be really on top of the current trends, and you need to have good communication skills. So that is what I realized. Once you become a professor, it is not about writing papers. It is also about communicating with people, doing solid presentations, understanding the people, not just telling yourself, but look at what people are expecting from you, and just understand the problem that people are trying to solve and offer a valuable solution to it. So that is usually how you can get your hands on the funding. And to be honest, it takes a lot of time to master writing good proposals, getting good connections. But once you get it, so that's one of these things, once you know how to do it, then it's a skill you can use for life. At least that is how am I seeing it.
Thank you for your answers, and that was mostly it for the research and academic part.
Maybe before we go into the other part, I believe I didn't get to have a chance to talk about the current projects we are doing.
Yeah, I was going to ask about that. Yeah, you can.
Yes. Yeah, so maybe before we close the research part, I can talk a little bit about the current exciting stuff we are working at, so the people who are listening out there, has an idea about what kind of deep RL research is being done in Turkey. So I will try to quickly summarize the current stuff that I'm involved at. One of the big applications of deep RL is on autonomous systems, so that is what we are working at. And I am also lucky enough to be working as the director of artificial intelligence at e-tron Technologies, which is an autonomous driving company who is based on Istanbul and United Kingdom. And that is where we actually do a lot of deep RL research applied to autonomous driving. And we are basically looking at problems, how you can apply reinforcement learning to, for example, tactical decision makings for self-driving cars. So that is, if I am, for example, driving, so if the car is driving itself on a, let's say, highway, which lane it should switch to based on the perception it gets from the surroundings. So for example, should I keep my current lane, or if I maybe switch to the left or right lane in a safe manner, then my performance will be higher, like I can get to better speeds and stuff like that. So one of the fascinating things that we got into during this project is, if you actually set up a small simulator, then this is not a super challenging deep RL problem to solve. Like it is definitely not something like, you know, playing Go or playing StarCraft, something like that. So this is actually a much you know, easier deep RL problem. But the real challenge comes once you start applying this to real life. So at e-tron, we are lucky enough to actually have a car which is completely instrumented so that you can actually do autonomous driving in the highways of Istanbul. And once we started deploying these algorithms to real life, we started seeing challenges that are, I believe, one of the fundamental obstacles in front of deep reinforcement learning research. There are fundamentally two challenges. The challenge number one is safety and generalization. It is very difficult to guarantee, put bounds on the safety or the confidence levels of your neural network. So this has been a research topic from day number one when people started doing the subjects. But to me, it is still fascinating that we still actually didn't come a long way in terms of, you know, putting formal guarantees and, you know, safety checks on neural networks. Because if I put a neural network on a car, then I should be really be careful about if it is going to, you know, crash or if it is going to get into an accident or not. And it is very difficult to guarantee that this car is never going to go in accident under this and these conditions. So we do a lot of research on these subjects where we can assess that under these you know, conditions, my reinforcement learning agent is never going to crash. So that is, assessing the safety is a very important subject. Another important subject, once you are doing autonomous driving in real life, is how to actually transfer what you have learned from simulator to real life and how to transfer what you have learned in real life to the simulator. So most of the research in reinforcement learning is done in simulators because due to the nature of how the problem is set up. But then if you learn everything in simulator and then execute in real life, you see a lot of gaps. So how do you close that gap? Like how do you guarantee that what you train in simulator can work in real life? And then what you learn in real life, can you bring that back to the simulator? And I'm not talking about super hyper-realistic graphics and stuff like that. I'm talking about behaviors of other people. Like how do I get a super realistic traffic model of Istanbul in a simulator such that I can see people are doing all these mistakes as stations and crazy stuff so that I can actually build a reinforcement learning agent around it. So that is one of the main research topics we are working on as a joint research collaboration between e-tron and ITU. So that is what we do, safety and simulators. Yeah. Another very interesting project that we are just about to start is a project funded jointly by Aselsan and Savunma Sanayi Başkanlığı. It is called Hamle, and it is about applying multi-agent reinforcement learning for military decision making. So it is kind of like StarCraft in real life. We are really, really very hyped about this project because it will enable us to, you know, I believe it will enable us to create a huge impact on how multi-agent reinforcement learning is being done. So the biggest challenges there, apart from imperfect information and all that, is just vastly how big the search space can get. It is enormous. And we are working on some novel use of how to use graphical neural networks and other kinds of decomposition techniques that will allow us to learn how to take these huge decision-making problems and simplify it into simpler pieces, embed it into a space where the decision-making problems can be solved in a much more efficient manner. So that's a project that we have just started, I would say, although on the theoretical parts we have been working for a while. So that is another thing that I'm really hyped about. And other project that I want to talk about is there's a project that we got recently funded by European Union about how to apply advanced AI methods in manufacturing systems. So this is a huge project where we are collaborating with a lot of different partners, both from Turkey and all across the Europe. And what we are trying to do there is how to actually embed useful domain knowledge into real problems such that when you apply either classical deep learning or reinforcement learning, how you can actually truly extract knowledge from the existing work that is being done on the subject so that you can come up with machine learning systems that can work on much smaller data and they can actually obey the constraints that are given by the environment. So that's a huge and open problem in practical artificial intelligence. A lot of these systems, they do not have any guarantees on constraints. So when you apply, for example, an artificial intelligence system in manufacturing, you can never say, this is going to do mistakes by this amount, or it is never going to do mistakes on, this kind of applications. You can never say that. But we are going to discover novel ways how to embed basically knowledge graphs into manufacturing systems, so we can actually learn how to close the gap between application and theory. And also, lastly, I would like to mention Lisa, another company that I'm involved with. It is about, it is actually a much different application than compared to all these applications. It is about predicting. It is basically an iPhone. It's basically a smartphone app where you can actually use to predict what kind of engagement your photos are going to get when you post them on Instagram. So you can actually look at a picture and you can predict like how many people are going to get how many people are going to like this picture and stuff like that. And right now we are not using any reinforcement learning on that, but now one of my future research goals is actually turn that into a reinforcement learning problem, where you can actually come up with a decision how to make your posts in any social media, such that in the long run you get the maximum engagement from people who are looking at you. And it might seem like like not as problem as important as the other ones I mentioned, but there's a huge potential there. If you actually take it from the user domain, and if you look at the commercial domain, then it becomes about advertisement planning. A lot of advertisement today is being done from social media. So if we can develop more methods there which can truly unlock the potential of reinforcement learning, then you are basically selling a tool to advertisement companies or any entity who wants to plan their advertisements. Like, if you plan your posts, your pictures and stuff like that in this and this manner, this is your strategy, then you are going to get the maximum amount of engagement and maximum amount of business impact in the long run, which I believe is going to be a very important application of reinforcement learning to planning in general in real life. I believe that's all. So there are a lot of other smaller projects, but that is like what the majority of my time is being spent on nowadays. And I would also like to tell the people who are actually looking at, listening to this podcast, listening to this video conversation. We are always taking new students. So if these problems are, exciting to you, always feel free to send me an email, and we will see what we can do. So sorry for the little bit of self-advertising.
No, that was very helpful for students, especially in Turkey. And they want to, maybe they will have better idea what's currently worked on the project universities.
I also wanted to portray that, there's not a lot of, exciting AI research in Turkey. There are amazing researchers, but their numbers are small. I would say there are only a handful of professors who are, doing high impact research in Turkey, but they are there. So I just want to encourage students to look out. So if you look out, there are people who are doing a lot of exciting work in deep learning and deep reinforcement learning in Turkey. So you can always, get in touch with those people, and you can get involved in interesting projects. So do not feel demotivated because you're in Turkey. So that is what I'm trying to say. There are a lot of good researchers here.
For that information as well.
Actually, I take my all answers for my questions, but I wonder, what are you thinking about semi-supervision, self-supervision, meta-RL? Because it's a very big topic, and nowadays RL researchers not just research about RL. Actually, for me, I think it will become a maybe it can be very big word, but general AI problem, because RL makes a bit I don't know, philosophical thing for me. What do you think about that?
So yeah, those topics are super interesting, and I do believe that they will set the research environment for the upcoming years. So people just start to get a feel of semi-supervised or unsupervised learning in general. So they were always there, but there weren't a lot of successful algorithms and applications, and that is slowly changing. For example, in terms of semi-supervised learning, so most of my experience in that domain actually, again, comes from computer vision. For example, just to tell you about some of the recent experiences we had using those topics, in the company that I just mentioned, Lisa, we were mostly doing supervised learning before. But then the problem there is, like I said, the problem there is you post a picture and then you want to predict how many likes it's going to get. And you can see how difficult it is to get a lot of good labeled data for a problem like this. So then we started, looking into unsupervised learning. Like, there are a lot of pictures out there, and there are not any likes on it, but there are a lot of pictures out there. So can we, for example, learn some unsupervised representation for all the pictures on social media, such that it actually helps to the supervised learning for sample efficiency and representation quality in general? And we did a lot of work. So we were working heavily on this for the 6 months or so, and we got amazing results. The results that we get, are much better compared to what we were doing before. And the new version of the app will be out soon, and I urge everyone to check it. It's not only predicting likes, but it's also finding similar pictures, for example, to get you inspired. For example, you post a picture of Golden Gate Bridge, but then you ask, what are the good pictures of Golden Gate Bridge out there? And then you query that picture, and it gives you similar Golden Gate pictures, but which got a lot of engagement from Instagram users, a lot of likes. So, for example, things like that, we couldn't really do that with supervised learning, but with unsupervised learning, semi-supervised learning, actually, to be precise, we really, improved the representation quality of computer vision by a large margin, the computer vision algorithms that we were using. And I believe that is also going to dominate a lot of other areas as well. And we have already started seeing, people using that reinforcement learning as well. So I believe semi-supervised is only going to get bigger and bigger, especially in computer vision and in other domains in general. In terms of unsupervised learning, so unsupervised reinforcement learning is getting a lot of attention, especially from people who want to solve real-world problems. And we've started dabbling in that subject a bit. And one of the things that we have realized is once you are not getting a reward signal from an environment when you are trying to solve a reinforcement learning problem, but instead you are trying to rely on other things, such as building skills or predicting the future and stuff like that, it can really be beneficial. It really improves the speed of convergence on a lot of applications. But the most fascinating part, and the part that we want to explore, is basically how does this relate to transfer learning in general. So that is one of the underappreciated areas of reinforcement learning. Like, once you solve a problem, how do you transfer the knowledge of that problem to an unseen reinforcement learning problem? And to me, that is the only way to unlock true potential of these applications. Because, I don't want to give a lot of examples from how humans behave or how humans do this type of stuff. But whenever somebody tells me that, hey, a human can do it in n steps, why does it take, billion samples for an RL algorithm to figure this out? Because I believe the answer there is because humans can do transfer learning. For example, if I learn how to play a game like Pong, and if you give me another version of Pong, which is kind of similar, but it is not the same game, I will probably play that pretty well. Or, for example, things like this. If I learn how to play Pong, and then I basically understand that there's a ball, and if I hit that ball, it is going to bounce off. There's like simple physics there. Then you give me Breakout, the problem where you need to destroy a lot of bricks. Then I know that when the ball comes there, because of my experience from Pong, I know that most probably if it hits, it is going to bounce. So you can see that two completely unrelated problems, but I can take one thing that I learned from there and I can transfer it to the another. That is, I believe, why humans are so efficient in learning a lot of stuff, because they can use a lot of prior knowledge, abstract knowledge from different domains and adapt it to new domains. And I believe with this unsupervised reinforcement learning, we will be able to do that in an automated manner, so that I can learn how to drive. And if I know how to drive, maybe I can transfer that a little bit of that knowledge to other navigation tasks. Or if I know how to learn StarCraft, I can transfer that knowledge to red alert as well. So I'm just making this up.
Yeah.
So I think unsupervised learning will enable that, and that's a fascinating direction to study. And that actually also ties in with another thing you mentioned, meta-RL. So yeah, I think that is super important. So meta-RL can mean a lot of things, but to me, developing algorithms which can take a problem, decompose it into smaller problems, or find the connections between different problems, those are very valuable. And I think those are going to dominate the next 10 years of RL. And of course, this is this might be completely wrong prediction. It is very difficult to predict the future, but that is what I feel like, and that is what I want to do research on too. So the Aselsan project that I mentioned, so we are going to look into that. Like if I solve like a particular military decision-making problem, how can I solve a related problem? Or even more fascinating, so that is a dimension that we really want to discover, how to decompose problems into simple problems, kind of like curriculum learning, but in an automated manner. Like if you give me a very complex problem like StarCraft, if I look at the whole StarCraft, observe a lot of StarCraft, can I say that, hey, before I solve this game, first I need to figure out the resource management. Like I need to figure out how to mine the minerals. And then attacking is a completely different problem. Then I need to focus on that. So figuring out those kind of decompositions in an automated manner, it is very far away. There is nothing that can do this right now. But those are the things that I think will going to be popular. And like I said, our research group is focusing on a lot of aspects like that.
Thank you for that. And I have a little list of the questions that I have. You can maybe not answer all of them, but if you have anything particular interest, okay. And this comes from the Serfli, I believe it's how it read, and he wanted to ask which RL method will be promising in the real world, controlled and autonomous driving, model-based algorithms or model-free algorithms, he said.
Yeah, so again, there is no direct answer to that. I believe nobody knows. Well, if you look at if you just look at it from a theoretical perspective, model-based RL should actually outperform all the methods, right? Because just on paper, model-based RL is a great idea. Why? Because the main idea is you actually build a model out of all the observations that you see, and once you have a model, you can do planning on it, right? And actually, before the deep learning revolution, that was one of the most promising directions. Like I said, most of my PhD was on model-based RL, but not using deep features. It is mostly using binary features or linear function approximation type features. But it turns out that once you go into the deep learning framework, somehow it becomes very difficult to make model-based methods work. A lot of people are working on the subjects, and there have been some successes, especially in the robotic manipulation domain. But it seems like there is no general method right now, which is completely model-based and that can actually outperform model-free methods. As an outperform, I usually mean sample efficiency. Like it turns out that most of the time, when you want to build a model, it takes almost the same amount of samples to build a policy or build a value function in the first place. So my heart wants to say model-based because of it makes a lot of sense and because it is much more interpretable, usable, and stuff like that. But right now, model-based RL is not there. So a lot of additional research needs to be done so that we can get model-based RL working. In terms of autonomous driving, I will say the methods that right now, especially models that you can actually analyze and give formal guarantees, those are the ones that matters. So because safety is a huge part of autonomous driving. So unless you can put some important safety guarantees out there, your neural network is not going to be that much reliable. So I will say that whatever reinforcement learning approach, you can verify working on simulation and verify that it is working in real life, go with that. So I think that is much important than performance right now. But again, assessing the safety of neural networks, that is, like I said, an ongoing research topic. So that was kind of like a non-answer, but hopefully...
Yeah, no, that was very helpful. And the other question I have that was very, high-pointed in that we asked this on the Reddit yesterday, sorry. And it was about what's the least promising thing in the deep RL that people are wasting their time and money and their public funding is being vested on. I mean, I don't think any research is like wasted, but it could be spent on other things that could be more useful.
I understand. Wow, that's a really good question. And so, for example, things that I'm trying to stay away from, like I say, are basically any method that is only scalable with amount of computation you throw at it. I don't think it has long-term. I don't think it is going to have long-term returns. So how can I say that better? So let me try to give an example. For example, look at the achievements of DeepMind, right? AlphaGo, AlphaStar, they are amazing achievements.
Yeah.
But even they kind of stopped, working on those directions. And they are trying a lot of different stuff. And I believe the main reason is the amount of computation, amount of resources you need in order to implement that stuff is just crazy. So basically, I'm trying to think how to express my idea better. So basically, if you want to, for example, apply those algorithms in real life, nobody is going to give you that much resources in order to solve a business problem or in order to solve another problem. So we need to come up with ways which can take these methods much more resource friendly and much more sample efficient. So any algorithm that it seems like it is going to require billions of samples or it is going to require billions of GPUs, I think we need to get away from this. So these were important in the beginning because we needed to show even if these algorithms have the power to do this stuff. So that was definitely a big win for artificial intelligence when they showed that if you give me a huge amount of computational power, then you can solve problems like this. So for that aspect, those works were great. Those works were very valuable. But now we know that, yes, these algorithms can work. Now we need to, I think, scale down the computation part and instead focus on working on algorithms which offer much more valuable insights, where we can do more with less computation. So I would say, and I think those companies are also trying to move in those directions. Because otherwise it is not sustainable. There's only a limited amount of money you can put into high performance computing. If you are trying to solve a very big and unified important problem, maybe it's okay. But if you want to turn this into a business, if you want to solve real world problems, then the current solutions are not scalable. So we need to focus on that. Hopefully this made sense. Yeah. So I'm definitely not trying to diss all this previous work. But like I said, I think the era of putting billions of dollars to computation should be gone. Instead, we should focus on sample efficient methods. And one thing we should focus on is actually the theory, that I would say. That is one of the reasons why all of our methods are so sample inefficient, and because we are basically shooting in the dark with a lot of these methods. So for example, one of the reasons why you need to make an RL, such RL algorithms takes a lot of time to converge, we need to do a lot of hyperparameter optimization. So for example, there's a research topic that you should not work on. If you are working on an algorithm which requires super careful tuning of a lot of hyperparameters, I think that is not useful. Because then I need to do a lot of hyperparameter search, which is just crazy. Like, in order to get the algorithm to work, you need to find the golden setting such that, the algorithm converges, and otherwise it might not converge. And that is mostly due to lack of theory. So the one thing that I'm really missing from control theory, which is completely absent in almost all of reinforcement learning, is in control theory, you can write a lot of theorems, and theorems are like this. If you give me this system, and if you start the algorithm under these conditions, the algorithm will always converge. So that is what control theory says. Yeah. In RL, in a lot of deep learning, we do not have this. So I cannot say that if you give me an Atari game, and if those Atari game has this, kind of transition probabilities, and if my TRPO agent is initialized under these parameters, algorithm is going to converge. You cannot tell that. And that is why, because we don't have that theory, now we need to do all this, shooting in the dark, hyperparameter optimization. And a lot of our hyperparameter optimization is just blind search. Like, we are not doing that in an intelligent manner too. So we need to come up with a better theoretical understanding of how deep learning and deep reinforcement learning works, so that instead of randomly trying parameters, we can actually come up with theorems that guarantees that these algorithms are going to work under these conditions.
That was very helpful for this question. And there's another question which talks about RL and with the trading time series like stocks, FX. Do you see it's something that is useful to research, or it's just a buzzword for investors or getting funds?
Yeah, so I'm not a huge expert on these topics, but based on the things that I saw, yes, RL can be beneficial there. I mean, I've seen some interesting papers where they, show that RL can work on the settings. But the things like stock prediction, I think the challenging task is not the RL part; it is the formulation of the problem part. So the problems like these, what I would call problems that are very sensitive to a lot of features. So that is why stock prediction is a very difficult problem, because if you are just looking at the time series, you cannot really predict the long-term outcomes. You need to take a look at a lot of other stuff, like you need to watch the news, you need to look at newspapers, you need to look at all kinds of other things, and it really becomes a very difficult multimodal problem where you are not looking at time series, but you are also looking at lots of other information. And right now in RL or in deep learning in general, multimodality is a huge challenge, I would say. Currently, how we are handling multimodality is, for example, if you are getting an image data and getting a text data from two different sources, we just put them into separate embeddings and then we concatenate them. So we are just like gluing them on top of each other, which to me, it works. We know that it works in some settings, but to me, I think that is not the right way to do it. I'm feeling that we could come up with a much better embeddings, or we can come up with a much better ideas how to deal with different data resources, how to combine them instead of just concatenating them on top of each other. I'm sure there are works on these subjects that I'm not aware of, but I think in order to truly tackle problems like stock prediction and stuff like that, we need to spend more time thinking about embeddings. But if your time series problem is a problem like that, if even the autoregression, just like looking at the past and predicting the future kind of works, then I think then in that case, RL can be helpful. For instance, another project that I didn't mention, it just recently ended, but maybe we are going to continue working on this year, is a project we did with Migros. In Migros, we were looking at how to forecast the sales data. This is a prediction problem, not a reinforcement learning problem. And we saw that if you look at, for example, the past data, and if you look at some other multimodal data, not a lot, then you can actually very reliably reliably revise your forecasts. So, for example, that is kind of like a time series prediction problem that can be handled with current methods. And now, if you put reinforcement learning on top of it, you can do, market optimization, stock optimization, and stuff like that in the retail setting. So that's an interesting problem that we want to explore in the future. Hopefully, this helped.
Yeah, hopefully it will. And there is another interesting question, which talks about the impact on the society of the. He talks about the supervised learning and such as NLP, speech recognition, generation, and computer vision applications are deployed in the real world, used by actual people all the day in this real life. But what have to change for RL to have that kind of effect? Would it be like computationally cheaper to train algorithms or generalize better to be affected like the other methods? You mentioned the transfer learning as one thing, because from what I see, even if you just duplicate one paper, even something like a seed of the algorithm, random seed, whatever, it can change it. It will break the RL, because in the other settings you will still get results that's near to what the others say in the paper, but in the RL, I believe that's problem. And the question is about that. What should be changed in the RL to have impact?
Yeah, that's a very good question. so from business perspective, like having RL that are working in companies or working as a part of societal problems, like the things that you mentioned, the number one problem is, like I said, robustness and stability of these algorithms. So right now, the way we handle it is like huge hyper parameter optimization, which is a huge waste of computational resources. So this thing can only be done if you are Google, Facebook, or something like that.
Yeah.
So yes, the first thing that we need to fix that. We need to come up with algorithms that has, at least some kind of guarantees, so that we don't need to, run 20,000 different variations of these algorithms and pick the one that actually won the hyperparameter optimization game. So robustness and stability is a big one. Safety is another big one that I mentioned. For example, if you put this on an autonomous car, or let's give a different example. Let's say on a drone, okay? Yeah. So let's say that I developed a reinforcement learning algorithm for navigating the drone for some kind of applications. I need to guarantee that this guy is not going to crash. This guy is not going to do a kamikaze or something crazy. And right now there is no way to do that. The best you can do is I tested 20,000 different variations in simulations, and it never crashed. And even that doesn't happen. Believe me, even in simulations, you can always find stuff that it crash. So I believe what we need to do is, and that's again a research problem that I've been thinking for some time, is we need to come up with a method so that how we can do constraint optimization in deep learning systems. So I believe that is another big open challenge. Right now, all of the methods that we are using, both for deep learning and deep RL, is unconstrained optimization methods. We are using stochastic gradient descent, which is good for finding local minima, but it doesn't tell you anything about what kind of things this neural network need to constrain. For example, let's say that I am doing policy gradient, and I say that my policy, it should never crash to walls, for example, for navigation problems. So the right way to do that is do policy gradient, like maximize the return of the policy. But once you are doing that, constrain such that the policy never do this, stupid stuff. We don't know how to do this, because when you do it with gradient descent, it doesn't need to obey the objectives. There is a naive way to handle this. The way we handle constraints currently in reinforcement learning is we take that constraint, we give that a huge penalty, and we put that into a reward function, and then it messes up with all of our reward dynamics. So for example, we say that if you run into a wall, I will give you -1 million rewards. And yes, it kind of works in some settings, but because it messes up your reward scale, it messes up your training dynamics. So what we really need to do is we need to develop optimization methods which can do constraint optimization both in deep learning and deep RL, such that we can obey a sort of constraints that are specified by humans or like specified by some other entity. Until we can do that, I think most of these methods are not going to be reliably executable in real life, unless there's a very strict controlled environment, such as warehouse robotics or something like that.
Yeah, that was very helpful. And
we have a question from the group, but it's, I think,
is it a question in the chat?
Yeah.
Okay, so should I look at it? Should I answer that?
Maybe we can, but I don't know.
Should I read it?
Yeah. I can. But I have one question also for you before that. What do you think about inverse reinforcement learning and maybe logic guidance in reinforcement learning?
Yeah, so so here's my experience with inverse reinforcement learning. First, I wasn't a big fan of it. When I started doing research in this topic, I was a purist. I would say that the true RL methods do not need any intervention from humans and stuff like that. Okay, so I was like a bit of a purist. But then I started working on real life problems, such as autonomous driving or autonomous drones and stuff like that. And I quickly realized that in order to really get the behavior that you want from an RL algorithm in a realistic setting, you need to do a lot of reward shaping, right? I mean, that is the thing I mentioned. You need to put a lot of negative rewards. You need to put a little bit of, encouraging rewards to the states that you want. And then I said, hey, this is not pure either. Like, I am engineering the reward function, but like it shouldn't work like this that way. So then I saw that if you are trying to hyper engineer a reward function, a much better way to do that is, do not do that. Instead, give the algorithm some guidance, give the algorithm some demonstrations, and then let it learn from that. So, and I believe right now, as of currently, that is the only way to get, fast and reliable reinforcement learning demonstrations for real life problems. And to be honest, if you just care about solving a problem, why not use all the information? Like, why do you want to solve it from a purist, model-free point of view? If there are demonstrations, if there are past experience, use that. And that usually helps a lot with the scalability of the algorithm. And I believe that is how, for example, AlphaStar was done, right? I mean, it wasn't pure reinforcement learning. They did use a lot of prior experience. And otherwise, if you are solving a complicated problem, exploration becomes impossible. Like, I mean, in model-free RL, all you are doing is, do random stuff until something good happens. But if you are in a very complicated environment, observing some good stuff by just, random behavior is almost impossible. Again, I think this is going to be solved by transfer learning, but until it is solved, which can be in like 10 or 20 years, we need to rely on observations from humans if we want to make RL work in real life.
That was very helpful. And I have one, maybe last question, or we can continue if there's another questions. And
Yeah, we can.
Okay. We have a lot of questions, but I didn't want to take much of the time.
No, Urkan,
oh, sorry.
can we just answer this question in the chat? Because,
okay.
Yeah.
Okay, should I read
I forgot that.
Umutcan, maybe you can read in the
Okay,
word.
as far as I understand, name is decentralized because execution of the obtained policy is decentralized in DEC partial observable MDP models, but in is decentralized training possible for partial observable MDP models, and what is your opinion about scalability of RL algorithms on these models?
Yeah, so yeah, that's again a very deep and difficult question. So yes, I think you got it correct. Most of DEC POMDP work is centralized training and decentralized execution. So it is kind of like you want to coordinate a group of agents. And when you train the agents, you train them, jointly in the sense that if you are doing offline training, you jointly train them in the sense that, you look at all the different combinations of outcomes and you look at the joint experiences and stuff like that. But when you're executing it, everyone is on their own. So they take the strategy that you have developed and they look at their local observations, and based on that, they come up with an action that they can locally execute. Is the decentralized training possible? Yes, it is definitely possible, and there is a lot of work on that subject. Actually, I believe a lot of multi-agent work by OpenAI is kind of like this. I think it is decentralized training as well. So scalability, actually the way, well, I would say that scalability is not the biggest problem when you are looking at completely decentralized. It is the stability that is the problem. So when you are completely decentralized, actually your search space becomes kind of like smaller because you are a single agent taking decisions for yourself. You can only look at a limited environment, like what is going on about the other stuff that's surrounding you, and that might not be a very big state space. But then executing this with all the other agents such that the overall outcome is positive, that becomes a big problem. So most of the DEC POMDP algorithms are very, very difficult to make them converge. So people do all kinds of tricks to make them converge. So centralized training is the one where you actually run into scalability issues. Because, for example, if I need to make decisions for everyone, then the action space is the joint action space of everyone. And if you've got 100 agents with only 2 actions, let's say binary actions, 0 and 1, then your dimension of your action space is 2 to the power of 100. So that is like a huge action space. But then it is stable because you are making decisions for everyone. So that is, I think, saying that my old advisor, Jonathan Howe, he always likes to say that distributed stuff, they are easy to scale up, but hard to stabilize. Centralized stuff, it is difficult to, scale them up, but they are much more stable. And so right now, again, there is not a good answer to how to solve these problems. But what people usually do, they try to balance a strike between the stability and scaling up stuff. And right now, I'm not currently, I don't know what is, for example, what I've been up to in the last 6 months of DECPAM-DB stuff. But the most recent stuff that I found out is like, it was mostly about how to handle exploration and how to handle, this complexity of stability and tractability together. So that is pretty much an open problem nowadays.
Thank you for that. But I have one relevant question.
Sure.
I am a musician also, and you are a musician. Have you ever tried to generate sound with RL?
Yeah, not with RL. Not with RL yet, but when I was a PhD student and when I was just learning about stuff like MDPs and machine learning and prediction in general, I messed around with algorithmic music generation. What I did was actually very simple. I loaded up a lot of MIDI libraries, and by using just the hand-coded information from music theory, I would design Markov processes such that the execution of the Markov process would make sense, that it will generate melodies that come from a certain scale. And it was very difficult to synthesize, meaningful music by just that alone, but it worked great as an inspirational tool. So I was able to write some electronic pieces, by creating a lot of random melodies using these Markov chains. And I would listen to them. Most of them were garbage, but some of them would say, that looks interesting. Maybe I can take that and use that. And I think use of machine learning for inspiration, I think for art in general, I think it is difficult to automate it completely right now. But with the current tools, it can serve great as an inspiration tool. And that is not only true for music, but for pictures, for art, painting as well. And I don't do a lot of composing anymore, but whenever I had to compose in the past, I use those tools extensively, not only in the context of electronic music, but metal music as well. So for example, I would want to write a bass solo, let's say, and I couldn't come up with interesting ideas. I would let my Markov chain sample a lot of ideas for me, and I would feed it in transitions based on my favorite soloists from either classical, jazz, or metal music. And sometimes they would find just 3 notes that blend so well together, then I can take the 3-note idea and expand on it. So like I said, it works great as an inspirational tool. For RL, I haven't actually applied that, but that would be a fascinating project. So maybe in the future, if I can find the right student and find the right funding agency, it might be an interesting experiment. Sure, I would love to work on that.
Yeah, it was very helpful. And I have another question that that would relate to my research area, hopefully, and that's about the offline reinforcement learning, which is very hyped in the recent months or last 1 year, which is basically, if you don't know what I mean from offline RL, it means it tries to connect reinforcement learning as a supervised learning problem. Instead of the collecting data in the simulation or a real world, stepping in the environments in the MDP, it basically tries to train on the offline data sets, which collected by huge, maybe robots or etc. And some of the people believe this is the future of the deep RL because, you can collect very big data sets easily, their MDPs, etc. And some of the people think this actually breaks the magic of the RL because it basically tries to turn to supervised learning problem. What do you think about offline reinforcement learning? And
Yeah, I think that's an important area. And like I said, because in real life, for most problems, we don't have simulators, we need to rely on some external data. And I think when you are trying to solve practical problems, yes, those things matter. But I think what all the previous experiences demonstrated that, especially the research on AlphaGo and AlphaZero demonstrated that if you are relying on, past data, like human data or kind of other demonstrations, you will always be, limited by that data. So it will be very difficult to bootstrap that. It will be difficult to improve that. So, for example, one of the things that I learned from AlphaGo, for instance, was initially it was mostly learning from human demonstrations, and then it would come up with a strategy. Then it would actually get stuck to some local minima because of those strategies. Once they've removed those elements, once the algorithm was able to play completely from self-play, completely from playing with itself, then that is the level where it got to actually defeat all the previous opponents, and it was able to generate those beautiful strategies. So I think for practical problems, the things you mentioned, offline reinforcement learning, learning from limited human demonstrations, that is definitely valuable. But I think we should always let a little bit of self-play, exploration, and playing against itself so that we can higher the performance. Yeah. Otherwise, it is just behavior cloning, like imitation learning. Yeah. Otherwise, we just imitate. And if that is what you care about, that's okay. But if you want to get superhuman performance or something more complex than the demonstration, then I believe you're always going to need a little bit of reinforcement learning.
Yeah, that, in my opinion, I believe these problems or these projects is actually being done to prove RL can be used efficiently in the real world, because these papers or the projects are actually done in the robotics, mostly real-life robotic yes. projects. And I mean, everybody is believing hype, but they can't like sell products or sell to investors. I believe these are the projects to demonstrate it can be done efficiently. Maybe it's something not in the like research focused, but yes, it's a research, but it's focused on the improving industrial capability, maybe.
Yes.
And
I mean, most of machine learning is done in industry anyway. None of the industrial executions of machine learning products look like academic research. There are a lot of domain knowledge. There are a lot of safety loops. There are a lot of, a little bit of, playing around with the parameters and all that. And yes, in RL, it needs to be the same. We need to pull some tricks in order to make it work in real life.
We didn't talk about, by the way, in the multi-agents. We didn't talk about the multi-agents, and there was a question relating to that. Sure. It's a 4-part question, but I'm gonna just, because most of them already answered, just one thing. What would be the most important, like, interesting papers or studies that should be worked if you're starting the multi-agent RL? Yeah, I mean, it basically assumes you have some knowledge of the RL, but no knowledge on the multi-agents.
Again, it depends on what kind of multi-agent you are working at. If you are looking at it from a decentralized point of view, my colleagues, Christopher Amato and Franz Olioek, so these guys are just great. They did a lot of relevant stuff in DECPOM DPs. So just go back to their earlier papers, I mean, before the deep learning revolution, because most of the actually challenging stuff in reinforcement learning is not only about the deep part, it is about the fundamental stuff as well. Like how you handle partial observability, how you handle exploration, how you handle communication and stuff like that. So you can just go and read the papers of these two guys I mentioned. And also, OpenAI is, of course, doing some amazing stuff on multi-agent RL. Like there was a lot of hype surrounding this emergent behaviors video that came around last year. So that is also that's also good stuff to look out for to understand what is the current trends. So that is what I would say. Also, look at a lot of related StarCraft papers. There's been some interesting, multi-agent point of view on those papers as well. And another thing, I think if you really want to get into true multi-agent reinforcement learning, you need to learn a little bit of game theory as well. And in order to understand the game theoretic perspective of reinforcement learning in general, DeepMind's Paris office, where my close friend from MIT, Shaigan, is working at, they're also doing great research there, headed by Carl Tully. So you can also check out the works done by them. They also have a great benchmark, OpenSPL, I think.
I know about them.
Yes. So also check out papers from them, and those will get you started. But like I said, get a good background on probability theory, so you can truly understand what partially observable MDPs are all about, and also get a good grasp of game theory. So that is what I recommend.
That's very helpful. Thank you for it.
Yeah,
and there was
we
a
have
question
one question.
in chat. Which one is?
Okay.
I was gonna read from YouTube chat.
kontrol.
A YouTube chat. Okay, should I go to YouTube?
Okay.
Or
No, I will read it. That was from the Murat Bronze nickname, and it asks.
Hello, Murat. Murat is a friend of mine. So, yeah.
Okay. He talks about adaptation in the real life deployed edge devices with the reinforcement learning, and he specifically mentions small quadrotors like 400 gram. Can we improve in these agents in the real life environments?
Yeah, that is another important aspect. So we haven't studied that problem in the RL perspective, but there's another computer vision project we are doing at our research center. It's a joint project with Arçelik, where we are trying to deploy computer vision algorithms on edge devices. And I mean, there are two things you can do. You can either do hardware optimization there, but let's say that that is out of our scope, the hardware is fixed. And then the second thing to do is what we would call network compression, like how to take these huge networks and compress them into smaller stuff so that they can work with less memory. Or they can, we can increase the inference speed. So there's been a lot of exciting research in that area as well, both in terms of how to learn how to prune these networks and how to actually quantize these networks and stuff like that. So right now, for some specific problems, you can really decrease the size of these networks very, very, very well. Like you can get them to, you start with 1 billion weights and you can get them to 100,000 weights, something like that. So your compression ratio can go crazy. But we really need to, so this kind of pruning, we still don't know how to do that very efficiently. So we usually either do it randomly or we do it using distillation. And sometimes you really need to get the network very, very small in order to fit it into a device like a drone. And that is a current research topic that we are exploring, like how to really prune or compress these networks. For example, can we learn how to do compression with reinforcement learning? That's an interesting problem. For instance, we know that RL works really well for neural architecture discovery, right? If you are looking for how to design a neural network, like how many layers should I add, how many connections I should add, you can do that with reinforcement learning. That is one of the nice applications. And another interesting application would be learn how to prune, learn how to compress networks using reinforcement learning, which is like an area that we haven't explored. But like I said, to answer the question, we either need to compress these networks, to do ultra, or we need to come up with better hardware. And the hardware part is actually very interesting. That is not a part I'm working on. But we have been recently, with my colleague Erdal Kayacan from University of Aarhus, we have been thinking about how to develop neuromorphic architectures, such that which uses alternative sampling schemes, such that inference of neural networks or spiking neural networks can be done much easier and much faster, so that we can actually use very big networks or very complicated. We do very complicated stuff on hardware that can be deployed on drones. So we just started working on this subject, so we don't have any findings yet. But hopefully, in a couple of years, we will have some interesting hardware where we can, both compress the network and run it on a very efficient hardware, such that we can deploy super crazy networks on drones. And in addition to that, if you are interested in hardware design, another one of my friends for a long time, Sertaç Karaman from MIT, he is also doing a lot of work on how to design hardware for light autonomous vehicles such as super light drones and stuff like that.
So
actually, I saw him in your thesis.
Sorry, what?
I saw him in your thesis, Sertaç.
Yeah, so so that's a funny story. So Sertaç and I, we go way back. So we studied under the same professor briefly when we were at ITU. Then he went to MIT, I believe 3 years before me. And after 3 years, I went to MIT. And by the time I was in the middle of my thesis, he graduated and he became a professor at MIT. And being a friend of mine, I asked him to be on my jury. And he kindly accepted, and not because only he's my friend, but he's also one of the world's leading researchers in autonomous systems in general. So it was very nice to have him in my thesis jury. And to this day, we are still in touch. Yes.
That was very helpful. And I believe we can continue, finish the English part, and we can maybe continue in the Turkish if you prefer.
Oh, okay. So that's it.
Evet.
Okay.
Türkçe, İngilizce arkadaşların sorularının hepsini tamamladık. Şu an başka bir şey yok. Türkçe'ye gelen bir iki
Okay.
soru var ya da genel olarak da konuşabiliriz.
Bir soru daha var da hani kontrol teorisi tabanlı
Alo.
birisiniz. İşte bu RL controller'larda bunun yerine geçebilir mi sizce diye bir soru.
Yurt dışı kargo?
Türkçe mi cevaplayalım, İngilizce mi?
Alo.
Yani İngilizce cevaplayalım ya.
Okay, so the question was coming from a control theory background, do I think that we can use RL in control theory?
Yeah.
It really depends on your problem definition. So if you are looking at a control problem where the model is known and there isn't a lot of uncertainty surrounding the model, then I don't think it actually makes a lot of sense to use either reinforcement learning or machine learning, because we got great theory behind how to design control systems. So for example, I know that if I design a PID controller under certain specifications, it is going to work, and it has been demonstrated to work. So why would I need to make it more complicated by introducing a model-free method? So to me, that doesn't make sense. Like completely ignoring control and putting RL in charge. It is interesting from a scientific perspective just to show that it can be done. So that is another topic. But from a practical point of view, I have differential equations, I have stability theory, I have Lyapunov theory, and all that great stuff. Why would I not use that? But there are some control problems where you cannot model it very well because of either internal sensor noise or because of the external noise. Like there's a lot of uncertainty and a lot of interesting control problems. For that part, I think it makes a lot of sense to work with put control theory and machine learning hand in hand and make them work together. So here are two examples from my research group where we recently did work on these subjects where control theory and machine learning were working together. Maybe we don't have a lot of time, so I will make this as quick as possible. One of them was a project we did with Turkish aerospace industries, and in that project, we were looking on how to develop fault-tolerant flight control systems. For example, you are trying to control a fighter aircraft, there is an engine failure. How do you land that aircraft? So the classical way to do that is using the fault-tolerant control is, whenever there's something wrong with your engine, you got an adaptive estimator, which actually looks at the engine response and tells you, hey, there's something wrong with the engine. And then you change the controller so that you can land. So that is the classical way to do it. But we discovered that if the engine failure is really severe, really big, then before you start estimating the failure, you are already crashed. So when there's a huge failure, then these things do not work very well. So what we did was we trained a deep learning estimator, which it looks at the engine, and by just looking at the first couple measurements, it can immediately predict if there is something is wrong with the engine or not. So we replaced that adaptive estimation part with a data-driven prediction where it can actually sense something wrong is going to happen much earlier than a classical warning system. And then once we deployed that, this was a joint work with my students and funded by Turkish Aerospace Industries. We saw that in simulations, we can immediately predict an engine failure, which in response would immediately reconfigure the aircraft for landing. So we showed that this works much better than conventional approaches. So this is like a good example of how control theory and deep learning can work together. Another example is from autonomous driving. So there is a paper we published at Intelligent Vehicles Conference. By the way, the other work I mentioned, it just got published in Aerospace Science and Technology. You can check it out from there. At e-tron, we have developed a reinforcement learning algorithm which can take an existing controller, such as model predictive control, and learn how to schedule that controller based on environmental, measurements you get from the environment. So one of the things, for example, in control theory, we don't handle very well is gain scheduling. So in control theory, you design a controller, but then you need to change the parameters of that controller based on different settings, based on different scenarios. And currently, it is done completely manually. Like you say that, for example, if the aircraft is in this altitude and if the aircraft speed is like that, do this controller. Or for a car, if there's another car in front of me and I am, at this speed, and if the road is not very bumpy, use this controller. So something like that. So we took that heuristic part out and replaced it with a reinforcement learning agent, where the agent looks at the environment and tries to select which controller I can use. So the actions of the reinforcement learning agent becomes really the settings of your controller, such that if I can sequence these controllers one after another, I get the maximum comfort or maximum reward from the environment. And we show that this usually works much better than the classical hand-tuned controller settings. So overall, what I would like to say, in a lot of settings, it doesn't make a lot of sense to get rid of controllers, control theory, and replace it with RL. But in your control agent, if there are some parts where you are using heuristics and where you are using data which is not explained by differential equations, that part, you can put a deep learning agent or an RL agent there, and it can boost the performance of the controller. And completely unrelated topic, but that is actually a trend that I'm seeing a lot of in my research. In a lot of existing work, it doesn't make sense to replace everything by deep learning, but rather using it as a boosting device. Another project that I haven't mentioned is an optimization project. We are working with General Electric on how to, for example, optimize schedules for aircraft crews. So that is usually done by classical optimization techniques such as integer programming. And we saw that integer programming should stay there, but if we also put a deep learning or RL agent there, it can really boost the efficiency of the optimization method in terms of selecting what should I optimize and when should I optimize. So to me, it seems like all the classical algorithms, whether it is control, optimization, or something else, they can benefit from data-driven algorithms like RL or deep learning in general.
That was very helpful. Mutcan, Türkçe'ye geçebiliriz istiyorsan ya artık. Zaten
Geçelim ya.
kalmadı.
Son soruydu. Evet.
Aynen. Hocam çok teşekkür ederiz biz genel olarak. Çok yararlı
Rica ederim.
oldu.
Hocam teşekkürler.
Evet, yararlı oluyorsa ne güzel.
Bunun dışında bir de Türkçe, yani Türkiye'de böyle yüksek lisansta sizin bu İTÜ'de sanırım bir de verdiğiniz ders var. Bir reinforcement, deep reinforcement dersi.
Evet.
Bununla ilgili belki biraz konuşabiliriz. Hani Türk zaten izleyicilerimiz için bu biraz daha olacak.
Evet. Şöyle deep learning ve deep reinforcement learning dersleri. Deep learning'i yüksek lisans seviyesinde, deep reinforcement learning'i doktora seviyesinde 2 senedir veriyoruz. 2 derste 2 kez verdik. Hatta DeepRL'in ikinci versiyonu yeni bitti. Yani dersleri yeni bitirdik. Yani dersler çok bence şey oldu. Yani onları improve edeceğimiz çok nokta var ama bence hani çok hani şey oldu, verimli oldu. Çok fazla ilgi var ve maalesef hani yüksek lisans doktora düzeyinde bu konularda bilgi alabileceğiniz ders hani Türkiye'de çok az, hatta yok yani hani bazı konularda. Deep Learning dersini yine merkezimizin kurucu üyelerinden Profesör Gözde İnal hocamızla beraber veriyoruz. Kendisi de Computer Vision ve Deep Learning alanında zaten çok önde gelen isimlerden bir tanesi. Onu 2 şube olarak açıyoruz ve açıkçası 40'ar kişi kontenjan olduğu halde ikisi de sonuna kadar doluyor. Yani bu tabii ki hani hem alanın başarısından sıcak olmasından dolayı hem de tabii ki yani dediğim gibi insanlar bu konuda kaliteli eğitim almaya şu an bir nevi açlar. Çünkü yani şeylerle bir yere kadar gelebiliyorsunuz. Görüyorsunuz internetten tutorial izleyeyim, bir şey yapayım vesaire. Hani bir avantajımız bu derslerin içeriği kesinlikle yurt dışında alacağınız derslere çok paralel. Hani bunların sulandırılmış versiyonu değil. Hakikaten hani bu konuda hani en fundamental bilgi neyse hem de bu konuda dünyada ne research yapılıyorsa onu veriyoruz. Ödevlerimiz de bu kalitede. Hatta ödevlerimizin zorluğu da meşhur. Hani gerçekten hani bir MIT'de alacağınız ödevden bir fark yok bizim vereceğimiz hani ödevlerin. Gerçekten oradaki öğrenciler ne tarz zor şeylerden geçiyorsa bu derste de onlardan geçiyorsunuz. Projeler yapıyorsunuz. Bir de hem Gözde Hoca hem de ben hem de aslında AI merkezindeki birçok hocamızın işte çok fazla pratik tecrübesi olduğundan dolayı projelerden bunları paylaşmaya şansımız oluyor öğrencilerle. Bence öğrencilerin asıl alacağı fayda da bu oluyor. Şimdi hani çok fazla eğitim programı var dışarıda ama hani maalesef birçoğunda hani deep learning'i de zaten öğrenmiş ve anlatan insanlardan öğreniyorsunuz. Yani öğrenmiş, bu konu üzerine bir sürü çalışma yapıp anlatan insanlardan öğrenme şansınız olmuyor çoğu zaman. Tabii bu kurslar şeyler kesinlikle çok önemli eğitim şeyinin büyümesi açısından ama dediğim gibi hani bizim buradaki artımız birçok hani hem research'tan hem de projelerden gelen bilgilerimizi de paylaşabiliyoruz. Bu da öğrencilere çok faydalı ve ufuk açıcı oluyor açıkçası. Tabii bu dersleri nispeten yeni verdiğimizden dolayı hala hani materyali revize ediyoruz, genişletiyoruz. İşte ödevlerin ve projelerin skopları nasıl olsun? Hani bunları hala tartışıyoruz. Ama genel olarak aldığımız feedback olumlu. Bir de her dersin sonunda bir tane yarışmamız oluyor. Bu yarışmalarda da şu ana kadar sağ olsun yine e-tron sponsor oldu. Mesela Deep Learning dersinin sonunda İstanbul'da toplanmış trafik görüntüleri üzerinden obje tahmini yarışması var. Hani gerçekten novel bir dataset. Hani sağda solda bulamayacağınız İstanbul'a özel bir dataset. Bunun üzerinden öğrenciler object detection, computer vision algoritmalarını yarıştırıyorlar. Deep RL'de de benzer şekilde geçen sene Torx kullanarak yapmıştık ama bu sene direkt e-tron'un kendi geliştirmiş olduğu simülasyon environment'ında yapacağız. Otonom araba yarışı sanal ortamda tabii ki hani gerçekleşecek. Öğrenciler geliştirdikleri algoritmaları hani bir araba yarışında kullanma şansları olacak. Onu da Temmuz sonu gibi yapmayı planlıyoruz şu an için. O da bir Zoom etkinliği olacak. Herkese açık olacak. Onun da duyurularını vesairelerini yaparız.
Biz de retweetleyelim hocam.
Tabii sağ olun yani sizlere de kesinlikle duyuru hani paylaşmanız için göndeririz. Yani o yarışmalarda birazcık tabii machine learning'in ister istemez kompetitif bir ruhu var. Çünkü her bir algoritmanın bir accuracy, bir performansı var. Ve eğlenceli de oluyor açıkçası. Yani şu ana kadar aldığımız feedback olumlu ama tabii çok geliştireceğimiz yer var. İşte öğrencilerle de beraber öğrendiklerimizle bu dersleri kesinlikle Türkiye'deki yani en kaliteli deep learning ve deep reinforcement learning dersleri haline getirmeyi istiyoruz. Yani bu şekilde şu an derslerin içeriği. Yani şeyi de çok tavsiye ederim. Yüksek lisans programımız, bilgisayar mühendisliğindeki yüksek lisans doktora programımız hani gerçekten epey yapay zeka alabileceğiniz ders var. Bu konularda çalışan hani NLP'den tutun işte computer security'ye, klasik data mining'den işte ne bileyim medical imaging'e kadar aklınıza gelebilecek bütün hot AI topiklerinde hani dünya çapında araştırmacılar var İTÜ'de. Yapay zeka merkezimizde. Hepsi de çok güzel dersler veriyorlar. Hani yapay zeka üzerine ben yüksek lisans doktora yapacağım diyorsanız bence şu an İTÜ en seçeneklerden biri, en önde gelen seçeneklerden biri. Hem dersler açısından hem de bu dersler sayesinde iletişime geçeceğiniz hocaların hepsinin dediğim gibi çok üst seviyeleri var. Buralarda fon bulmak da çok sıkıntı olmuyor açıkçası. Biz iyi öğrencilere, hani promising research öğrencilerini mutlaka bir şekilde endüstriyel projelerimizden veya başka kaynaklardan fonlar buluyoruz. Yani kesinlikle yani iyiyseniz hem kabul almakta hem de fon bulmakta sıkıntı bulmayacağınız. Gerçekten hani yurt dışındaki, Avrupa'daki, Amerika'daki en iyi demeyeyim şu an için ama en azından oradaki en iyi yakın üniversiteler arasındaki kaliteye yakın bir eğitim ve research experience'ı sunuyor İTÜ şu an.
Bir sorumuz varmış sanırım. Bakayım. Bilgisayar mühendisliği İTÜ doktora başvurusu yaptım. Mülakat için ipuçlarınız nelerdir? Arkadaşımız bilemiyor, biraz yanlış bir soru galiba.
Yani ne diyebilirim bilmiyorum. Yani genellikle mülakatlarda şuna bakıyorlar arkadaşlar. Yani hani motivasyonlarınız ne olduğu ve kiminle çalışacağınızı belirlediniz mi? Hani mülakatta yapmamanız gerektiğini söyleyeyim. İşte niye bilgisayar mühendisliğini seçtim? Ne bileyim işte bilgisayar mühendisliği iyi para kazanıyormuş ondan geldim gibi falan böyle gibi absürt neden şeyleri istemiyor hocalar. Hani böyle çok planlı programlı girersiniz. Mesela ben şu hocayla konuştum. Bu hocayla hani şu proje üzerine çalışmak istiyorum. Hocayla da anlaştık. Hani hoca kabul alırsam benimle çalışmak isteyeceğini söyledi. Ben daha önce şunları yaptım, motivasyonum şunlar, research'ımda şunlara dokunmak istiyorum. Yani böyle fokus, ne yapmak istediğini bilen planlı programlı insanlara genelde mülakatta sıkıntı çıkmıyor. Hani genel tavsiyelerim bu olur. Hani böyle rastgele bir yere girermiş gibi girmeyin de bunlara odaklı gelin. Onun dışında bazen nadiren teknik sorular da oluyor ama çok da olmuyor sanırım hani bildiğim kadarıyla. Yani daha çok sizin şeyinize bakılıyor. Stratejinize, planınıza ve motivasyonunuza bakılıyor. Zaten teknik yeterliliğiniz çoğu zaman işte diplomanızdan, işte ALES puanınızdan vesaire az çok belli oluyor.
Teşekkür ederiz hocam yine hocam için. Bunun dışında var mı Mutcan sende bir şeyler? Başka konu?
Yani benim aslında başka bir sorum kalmadı. Benim hani bir merak ettiğim konu daha vardı. Beni bazen çok heyecanlandırıyor. Özellikle Curiosity Driven algoritmalar.
Evet.
Beni RL tarafı gereksiz heyecanlandırıyor. Ben aslında o yüzden çalışıyorum RL üzerine. Çünkü hani yani işte meta tarafı var, Curiosity tarafı var, Evolution Guided tarafı var.
Kesinlikle.
Evet hani biraz da böyle maymun iştahlı olmaya başlıyorum bir yerden sonra. O da yalan değil yani. Çünkü hani ne tarafa baksam farklı bir algoritma var.
Evet.
Bakalım yani genel olarak aslında ben çok güzel bir söyleşi oldu bence. Çok teşekkür ederim.
Ben
Çok
teşekkür
mutlu
ederim.
oldum.
Sağ olun. Yani daha soru varsa biraz daha şey yapabiliriz hani 12'de bitirelim dedik ama sorun değil yani hani.
Yok genel olarak hepsini sorduk yani.
Evet bayağı, bir de siz zaten cevap verdiniz hocam bize sormadan.
Aynen. Elimizdeki soruların hepsini önceden zaten cevap aldık.
Vallahi
güzel oldu.
Bu kadar çabuk çalışa predictive capability'lerimiz arttı yani arkadan. Önceden şey yapabiliriz, proaktif davranabiliyoruz.
Genel olarak Bende de soru yok şu an başka.
Ben şeyi sorabilirim. Peki ya geçen Ekrem Hoca mesela bununla konuştuk. Aktif inference üzerine. RL'den başka böyle RL paradigmasına yakın bir e, aklınızda bir konu geliyor mu? Yani yine bu tarzda hot topic olabilecek.
Yani decision making konusunda mı?
Evet.
Yani sequential decision making deyince aslında RL değil de ben bunların hepsine genel olarak hani MDP optimizasyon metotları diye bakıyorum. Şimdi RL aslında şeyin bence special versiyonu gibi dynamic programming'in. Hani dynamic programming'de ne yaparsınız? Bir MDP'yi alırsınız, bütün state'leri sıraya gezer, üzerinde dolaşırsınız. Yani modeli biliyorsanız ve tüm state space'te dolaşabiliyorsanız bunun adı dynamic programming oluyor zaten. Hani RL bunun bütün state space üzerinde sequential şekilde dolaşmak yerine environment'tan sample'lar aldığınız ve modeli de bilmediğinizden dolayı expectation hesaplayamadığınız, onun yerine ne geldiyse sample onun üzerine ilerlediğiniz versiyonu. Yani aslında RL de yani çok umbrella bir terim zaten. Hani böyle RL deyince, daha doğrusu dynamic programming yani aklınıza gelebilecek her şeyi burada kapsıyor. Yani dinamik optimizasyon deyince açıkçası zaten MDP ve bunun varyasyonları var. Bunun dışında hani alternatif diyebileceğiniz biraz daha sembolik olan metotlar var. Sembolik planlama metotları hani böyle MDP'lerin üzerinden giden değildi. Fakat onlar da hani geçmişte çok popüler olmasına rağmen bir türlü istenilen scalability'yi yakalayamadılar. Yani benim bildiğim tabii ki. Hani kesinlikle başarı hikayeleri var orada da. Hani bu sembolik planlama hani metotlarında işte bunu biraz RL'le birleştirme, deep RL'le birleştirmeye çalışan insanlar var. Hani bu biraz alternatif bir paradigma olabilir. Bir de tabii ki good old static optimization var. Hani işte convex optimizasyon, non-convex, işte linear, integer programlama. Hani birçok aslında karar verme problemini bunlara da dönüştürebiliyorsunuz. Fakat hani tabii bunların çok inefficient kalıyorlar. Çünkü dynamic programming